So guys, can you solve this WAEC initial equation? Now this question might look a little bit scary for some newbies, but are just new to initial equations, okay, that prepare for WAEC exam. Now this question is actually very simple. So now there's one idea that we need to solve initial equations like this. What is that idea? Now, whenever we have equations like this and we're seeing powers, this raised to power and all that, we don't like it. We prefer our equations to be linear, okay? We have to eliminate this initial power and all that and make it linear. So how can we do that? In this case, the only way we can do that is by using one basic idea. What is that idea? The idea of initial equations that says that when you have a to the power of x, for example, that is when you have the same base at the left and the right hand side of an initial equation. Therefore, their power must be the same. Or you can say a cancels a, x equals what? Y. Okay, that's a basic idea we can use for initial equation. So what we're going to do is that we're going to make the left hand side have one single base and a power. Then the right hand side also have that same base and another power. So we can just equate their power like this. That's the simple idea we're going to use. So here now is that how can we now make this here have the same base as this? They're not even looking similar, okay? The bases here are 2. Then here we have a base of 8. They're not the same. So the base must be the same, okay, and also they must be exactly like this together. But here now we also have a fraction, and this one does not have a fraction. So we have to simplify this. But first of all, let's try to make their base the same. When we look at this now, we have 8, we have 2. We can express 8 as a power of 2, okay, because 2 to the power of 3 gives us 8. Now that's very good because we have eliminated this base and we have added 2. I've turned it to 2. So we can write this as 1 minus y times 2 to the power of y minus 1 all over 2 to the power of y plus 2 equals to 2 to the power of 3. The 2 to the power of 3 will give us 8. But don't forget, we must multiply this power here. Are you following? It must multiply the power here because everything here represents 8. So 2 to the power of 3 is 8. 3 must multiply this to give us this here. Now we are we're doing well because all the base are now the same. 2, 2, 2, 2, they are now the same. But we can't still use this here yet. Why? Because this one is telling us that they must be the same, exact same form. But here now they are scattered. We have 3 of them here. We have just 1 here. We need just 1 and 1. What that means is that we're going to use the law of indices to simplify this further. And now students will make one silly mistake. Okay, I made that mistake when I was in secondary school. Also, when I have something like this, because we are used to cutting and cutting when they are the same. So I might just say that, okay, innocent me will just say, oh yeah, 2 cancels 2 since they are the same. These 2 cancel these 2. Okay, yeah, so I'll not be canceling. Very wrong, please. That's why I don't like using this cancellation. I'd rather just compare their power, equate their power, because this cancellation might mislead you. Now, for anything to work like this, you must just have one base here and one base here, then we equate them. Not cancelling like this. Very wrong. So we have to simplify this by using the law of indices. Let's first start by simplifying the numerator, okay? According to the law of indices, when you're multiplying two index like this, you add their power. Pick one base. So here will give us 2 to the power of 1 minus y plus y minus 1 all over 2 to the power of y plus 2 equals 2 to the power of 3. Okay, let's multiply. 3 times 2 is 6 minus 9y. Can you see? Please don't do anything to these 2. Please don't cancel them out. Okay, now we are moving further. So here now, when we look at this, let's simplify this. We have 1 minus 1. Oh, gives us 0. Minus y plus y gives us 0 too. So this one gives us 0. This one gives us 0. So we have 2 to the power of 0 all over 2 to the power of y plus 2 equals 2 to the power of 6 minus 9y. Yes, we are almost there. Don't forget, we need just one base here, okay? What do we now do here? We have to simplify this fraction, join it together. Don't forget, when we are dividing like this, they have the same base. We're going to subtract the power. So this one will give us 2 to the power of 0 minus everything here. Let's put the bracket because of the subtraction, please. That's 0 minus everything here. Okay, law of indices will give us 2 to the power of 6 minus 9y. Yes. Now we have just one base. And according to this idea, when the base are the same, their power must be the same. So we can now equate the power, or you can now cancel out anyone you like. Well, let's equate the power. So for their base to be the same, therefore, so 0 minus is nothing. So we have minus y plus 2, 0 is nothing, equals 6 minus 9y, not q, 9y. Their base, the power must be the same. So by expanding the bracket, we have negative y minus 2 equals 6 minus 9y. So now from here, by transposing, okay, transpose or you subtract from both sides, whichever method you want to use, we're going to get the value of y easily. Now, if you make it this far, please don't forget to subscribe to my channel to learn more, to have more mathematical insights like this and learn a lot of mathematical stuff like this, okay? Thank you very much. So here now, let us transpose. Let's bring negative y here because positive. We have 9y minus y equals negative 2 transpose to that side gives us 6 plus 2. So 9y minus y gives us 8y plus 6 plus 2 gives us what? 8. So therefore, dividing both sides by 8, we have y to be equals to what? 1 as our final answer. Very, very simple. It's not hard. Please, if you have learned something, subscribe to my channel. It's very, very simple, okay? And also, if you have a question, drop it in the comment section. If you have more questions for me to explain to you, please drop it in the comment section. Also, so I come your way next time. Bye-bye.